In this video, I'm going to talk more on probability. We'll look at several different types of examples. We'll look at some examples where they give you a graph, and we'll look at some examples where they give you some information and they ask you to find probabilities from that information. Here's an example of a probability question. It says, the graph shown is based on more than 170,000 interviews done by Gallup that took place from January through December 2012. The sample consists of employed Americans 18 years of age or older. The emotional health index scores are the sample space. Right, so the emotional health index scores are the sample space. So not the occupations, the scores themselves are the sample space. And it says we randomly sample one emotional health index score. Here they're asking us to find the probability that an emotional health index score is more than 80. So we need to count up the number of bars that have a score of greater than 80. So I'm going to start by putting a line on the spot where 80 is, and that'll help us to be able to identify the bars that are greater than 80. All right, so now you can see that from manufacturing or production, which is the third one down, on, all of those are greater than 80. All right, so we're going to count up the number of bars. Here we go. And counting up the number of bars that are above 80 is helpful because that's going to help us find the probability. We're going to count up the number of bars that are above 80, and we're going to divide that by the total number of bars, which if you take a second to count those up, there's 14 of them. All right, so if you count through service, transportation, manufacturing, production, all the way to physician, there's 14 bars in total. All right, so let's count the number of bars above 80. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so the probability that an emotional health index score is more than 80 is going to be 12 over 14. Now, if they ask you to write this as a decimal, of course, you would just plug this into your calculator and write it as a decimal. Let's look at a different example. Here, instead of a graph, they're giving us some information and then asking us to list the sample space. So it says, a special deck of cards has 10 cards. 3 of these cards are green, 2 are blue, and 5 are red. So when a card is picked, the color of it is recorded. An experiment consists of first picking a card and then tossing a coin, which is either going to land on heads or tails. Right, so you're going to draw a card and then flip a coin. So the first thing we need to do is list the sample space. All right, so this is where we're going to list all the possible combinations that could happen during this experiment. So the first thing that they start off, they actually give us a hint. It says example GHGT, that means green heads, green tails. So that's the first 2 of our sample space. They told us that the cards could also be blue. So we have blue heads and blue tails. And then we also have red cards. So we could have red heads or red tails. Part B says, let A be the event that a blue card is picked first, followed by landing a head on the coin toss. So look at your sample space and figure out how many ways that this event can occur. So where you get a blue card first and then a heads. All right, so if you look, there's only one way that this event can occur. So you can only have BH, blue card, and then heads. All right, so now we know that there's only one way that this can occur. Now we need to figure out what the total number of events would be. So since we have 10 cards, this is going to be, the probability of A is going to be 1 out of 10. Next, we're asked, it says, let B be the event that a red or a green is picked, followed by landing a head on the coin toss. Are the events A and B mutually exclusive? Well, let me just remind you about what event A was. Event A was the event that a blue card is picked first, followed by landing a head on the coin toss. Now, let's think about this. A deals with having a blue card picked first. Event B deals with having a red or a green picked first. Right, so these two events could not happen at the same time. And since those two events could not happen at the same time, the events A and B are called mutually exclusive because they can't happen at the same time. You couldn't have a red or a green card that was simultaneously blue. And since A and B are mutually exclusive, one of our probability rules tells us that this means that the probability of event A and event B is equal to 0.